In this video, I'd like to talk a little bit about the problem that was brought up today in class. Now, I did point out that for this test this week, we won't see any limits involving trig identities, but it's still a good idea to talk a little bit about solving these, and I thought I'd offer my perspective on this. Now, this question did come from Khan Academy, and I think it's a multiple choice question online. Now, if you had a calculator and you were able to graph this, or if you had a calculator and you wanted to use some test points, I think the solution would become pretty clear. So a test points or a graph, if this showed up on a calculator permitted portion of a test or something like that, then these two methods would allow you to obtain a solution pretty easily. But as we were talking in class, I was thinking that this is going to be an example of a Pythagorean identity. And we could rewrite tangent squared as secant squared of x minus 1. And in the process of rewriting this, I just started expanding more and more. And I started to get a little bit nervous at this point because, for me, the next step would be to rewrite this possibly as 1 over cosine plus 1 and 1 over cosine minus 1. But we still have this 1 minus sine of x over here, and I just didn't quite see how this limit would resolve. There were no obvious components that are going to cancel. Even if I foiled, say, this group with this group, with the hopes of something canceling in the middle because of the difference of signs, I just don't know where this is going to go from here. And so I thought about it a little bit more, and even though Pythagorean identity is a good thought and we're ultimately going to use it, maybe using it right off the bat isn't the right thing. So seeing this tangent squared or a sine squared or a cosine squared, those are all good indicators to use a Pythagorean identity. But what ended up being a little bit more helpful in this case is taking this first equation and then using a definition to rewrite it, and then moving to our Pythagorean identity. So what I did the second time is I chose to rewrite tangent squared of x as sine squared x over cosine squared x. So the definition of tangent being sine divided by cosine, the definition of tangent squared is sine squared over cosine squared. So I rewrote that, and then I imagined the second binomial as a fraction over 1. This would allow me to multiply the two together. Now, I didn't bother distributing in the numerator. I left those separate, and we had sine squared times 1 minus sine x. So the numerator, again, could be multiplied together, but I chose not to do that just yet. And the reason for that is because this cosine squared of x, if we think of another Pythagorean identity, and these are all essentially rooted around this one Pythagorean identity, just modified forms of it. Sine squared of x plus cosine squared of x is equal to 1. So this cosine squared of x is really equal to 1 minus sine squared of x, and that's what I've written down here. And that's a perfect square, and so that's factorable. We have a 1 squared and a sine squared, and if we have a difference of 2 squares, then we can factor that to 1 plus sine of x and 1 minus sine of x. So I kind of noticed that back here, and that's part of the reason why I didn't distribute at this step. Leaving them separate allows for the 1 minus sine of x to cancel, and the fraction that's left over is something that we can directly substitute. And thinking of our unit circle, if pi over 2 radians is the position on top of the unit circle, sine, of course, is the y component of the coordinate here, which is equal to 1. So sine squared is equal to 1 squared. 1 plus sine, which was 1, is 1 plus 1, and we ultimately land on a solution of 1/2. So the tricky thing with trig identities, of course, is that establishing the identities or using the identities isn't always the most clear, and sometimes we get sidetracked. We do all kinds of work that's actually correct. Nothing in red here was wrong. There was nothing wrong with any of that. It just didn't get us anywhere. And unfortunately, that's just the way it goes. Now, with more practice, you'll become more comfortable with trig identities, and you'll notice some of the patterns along the way, kind of like what I described here. But in all honesty, it takes a lot of practice to become very good at this stuff. And even myself, after I'm out of practice for a few months, I tend to forget some of these rules and some tricks along the way. For students that had me for trigonometry last year, we ended up going on home instruction before we got into the heart of our discussions with trig identities, and so all of that was done at home. And so I'm a little bit nervous that that might be a weak spot in our understanding for class this year. So next time we get into heavy trig equations, we'll be sure to review much of that trig identity work before we use them in the calculus setting. So I hope the video helps. If you need a little bit more clarification, let me know. Otherwise, thanks for watching.